soccer ball is kicked from the ground with an initial upward velocity of 90 feet per second. The equation h equals negative 16t squared plus 90t gives the height h of the ball after t seconds. Part A, find the maximum height of the ball. Okay. Maximum. Does anybody know what maximum means?
The most it can be.
The most it can be. All right, so let's talk about the easiest way to do this problem. Gives us a lot of other information, but all I really care about is it gave me an equation. Okay, so I need everybody to open Desmos right now. And on Desmos, shows you, you're just going to desmos.com, opening up the graphing calculator. Is everybody there? All right. We are going to go to this equation, and we are going to type in the equation that was given to us. It actually doesn't even matter what the variables are. Desmos is pretty smart. It can figure out, so it doesn't have to be x's and y's. We can use what's given. So I'm going to go and I'm going to type in the whole thing. H equals negative 16 t to the second. So you have to use that little caret to type it in. Plus 90t. All right, I did go ahead and pull up Desmos just so I can kind of see if you guys are getting the right graphs. And hit enter. All right. If yours is set on the same window as mine, we're just seeing a little bit of red. If we want to see more, Desmos is really friendly. You can drag it, or you can use your little minus arrow to zoom out a little bit. So when I do that, I'm just going to keep dragging mine up here. This is my highest point. So can you guys just drag your screen so you can see that highest point? You have to use the caret. So if you do shift number 6, you can get into your exponent. Then you type your square and then use your arrow to get out.
It's 2.892.
And then you can use your screen. And so you can either zoom out or just drag. Drag it, so whatever you're most comfortable with, minus things out, or dragging, it's a long ways up there. We should be able to get to that. So, zoom out or drag it. And we can change the other, like the window that we're viewing, but that is sometimes confusing for people. It may take you a second to drag it where you can see it, but I think everybody should be able to. All right. So and then you can so move it down so you can see that point. All right, did everybody get that? You need to square, so shift. So now, all right. If I want to know this highest point, Desmos is really nice. I can see it right here. If I want to know what it is, I can click it, and it will tell me what it is. All right, so I want to know what the maximum height is. The height is the y value. The x is our time. So when I am looking at my question in my notes, so everybody look at that real quick. The maximum height is, what was that value? 126.56. And it tells us it was in feet, so that's the highest. How many seconds will it take to reach the ground? Okay, so if you go back to Desmos, if you need to recenter it, there's this nice little button over here called Home. You can click that and it'll take it back to where we started. This is when it started. It started on the ground, you threw it up. When it hits the ground again, that's asking when your height is 0. What's the x value? 5.625 seconds. So we are going to do these problems solely from Desmos. I am not going to make you work them out. I just want to practice using this feature to help us. All right, I want you guys to try number 2. So you have to go type in your equation and then see if you can answer the 2 questions from that. And I'll be walking around helping people. So I go to Desmos, delete out what's there, type in my new equation, h equals negative 16t to the second plus 64t plus 80. And if you have a touch screen, it's real nice. Otherwise, you can either use the minus to zoom out or drag it. And we want the maximum, so the highest, which is right here, 2,144. So my maximum height is 144 feet. All right, how many seconds will it take to reach the ground? So what happened on this one, it told us we launched the apple from the top of a platform. So this one, okay, it didn't start back here. We were standing up on the platform, threw it, it went up and came back down. So it hits the ground when my height is 0. There's 2 of them. Can the time be negative? No. So we ignore that one, so it's after 5 seconds. Okay. Try one more. Do number 3. H equals negative 16t to the second plus 25. The maximum is just your high point. So did you guys all get 25? Mm-hmm. And when it hits the ground, so if I'm looking, reset it here, when it hits the ground, obviously can't be a negative time, so we're looking for the positive, and that is 1.25 seconds. Is everybody getting Desmos to work for them? Okay. I want to do the very last example on this handout, and that's my last one. So this one tells me an astronaut on the moon throws a baseball upward with an initial velocity of 10 meters per second, letting go of the baseball 2 meters above the ground. The equation of the baseball pathway can be modeled by this. All I care about is the equation. So that's the equation when we're on the moon. The same experiment is done on Earth, in which the pathway is modeled by this equation. So obviously we know gravity's different on Earth and the moon, right? So the path of the ball will be different. How much longer would the ball stay in the air on the moon compared to the Earth? So what we have to do here is graph both of these things. So if I look at my first one, h equals negative 0.8 t to the second plus 10t plus 2. And I'm going to go ahead and do the second one as well. So just hit enter. You're going to that second equation and you're going to type in the equation for the Earth. You can see both of them on here. If you don't like that, you can do one at a time. The purple one, it tells me over here, it color codes it for me if you graph multiple things. So on mine, it did the first one purple and the second one black. Yours may be different colors, but it tells you which color is what. So I want to compare how long it takes to hit the ground. For the moon, the first one, how long does it take for that one to hit the ground? So I'm just going to say on the moon, let's just round that to 12.7. And then on Earth, the second one, when does that one hit the ground?
2.22.
Okay, 2.22. So if I want to know how much longer it took on the moon, what would I do with those numbers? And what did we get? 10.48 seconds. So you might be asked to compare a couple different graphs, but we're really just looking for the same thing on those. Do you have any questions?